All right, good morning, everybody. So, good morning, everybody. So before we continue talking about Java, I want to go back and just review very briefly and show you exactly what packages are in Java. And so in the previous lecture, I showed you how to import stuff or import classes from another package. You might wonder, what exactly are these packages? So the packages are just the way, is just Java's mechanism for organizing your code. And it corresponds to how your code is organized on your disk drive. So for example, if I go into my documents folder, so for the term 2024 fall in my 124 folder, you'll find my workspace directory or your workspace folder. So this is the workspace folder that Eclipse creates. If you're using Visual Studio Code, this folder won't exist. You can start anywhere you want. But in Eclipse, you get a workspace folder. And if you look in the workspace folder, you'll find all of your projects. Each project is just a folder or a directory. And so if you look in the lectures project, which is where the code I showed you was from last time, when you look in that folder, in Eclipse, you'll find a folder called SRC. Right? So again, in Visual Studio Code, you might not find this folder. But Eclipse does create this folder SRC. It also creates the one called bin. Now you have to be careful with the one called bin, especially when you go to submit your assignments. When you go to submit your assignments, don't go into the folder called bin. Right? You need to find the folder called SRC. And now when you look in SRC, you'll see there are a bunch of other folders. Each one of these folders is just a package. Right? So back in Eclipse, there's my lectures project. Right? In the lectures project, you'll see a source folder, which is the source folder on my disk drive. Inside the source folder, you'll find a folder for each one of these packages. Right? So there's the package floating point. All of the code for that simply lives in the folder called floating point. Right? And similarly, all of the code for some other package simply lives in the folder some other package. Right? And if you go inside any one of the folders here, you can find, hopefully, you cannot. I don't know if there's if there's a package that has a package inside of it. All right, so let's make a package with a package inside of it. Okay, so in some other package, you're allowed to make another package, which corresponds to a folder on your disk. So if I go into some other package and make a new package, I'm just going to call it, some other package dot XYZ. So when you do that, Eclipse might show you the package here. And if you go on your disk drive, when you go into some other package, you'll now find the folder XYZ, which is just the package XYZ. All right, so later on when we start to implement our own classes, I'll explain how the packages affect the name of your class. But for now, the packages are just used to organize your Java files. All right, so let's go back to the lecture material. And so we ended up on this slide at the end of the last lecture. So this was an if statement. Well, there's another function in Python. So max3 computes the max of 3 values A, B, and C. In Python, it doesn't matter if the values A, B, and C, what their values are, as long as you can write down greater than or equal to, everything's fine. Right? This will work for any type in Python. And so to compute the max of 3 values, you could write an if statement that looks like that. Right? And so if A is bigger than B, and it's bigger than or equal to C, then you know the max is A. Right? Else, if B is greater than A, and B is greater than C, then you know the result must be B. Right? If the result's not A or B, you know the result must be C. So there's the else part of the if statement. Right? Each time I assign to result, that's in a separate block. Right? And at the end of the function, I return the value result. So the corresponding method in Java looks like that. And so at the very beginning, I declare a variable called result. I don't give it a value. So I'm just gonna, it'll be in Java, I think its starting value gets assigned to 0, although I don't remember for sure. That's not true. No, so I have an uninitialized variable called result. And inside the if statement, I will set the value of result eventually. And so you have the if statement in Java looks a lot like an if statement in Python. There are some minor syntactic differences, but otherwise it has the same sort of structure, right? You have an if, you have else if instead of elif, and you have else just like Python has else. I'll come back to this slide and review all of the individual bits and pieces shortly. Right? Okay, so of course you can write max3 in a slightly different way. So you can start by assuming that the maximum value is one of A, B, or C. I'm just going to start by assuming it's C. Right? Then you can write your if statements. Right? So if A is bigger than B or C, and C, sorry, then the result must be A. Else, if B is greater than A and C, then the result must be B. Right? I've already assumed the result is C at the beginning. So if neither of these conditions are true, the result will be C. Right? So you can remove the else part. The whole point of this slide is that the else part is optional. Right? And of course, the else if part is also optional if you only need a one condition to test. Right? And of course, the else part of the if statement is also optional in Java. All right, so let's look at the differences now between Java and Python. And so your conditions in Java, they have to appear inside parentheses. You don't have a choice on this. In Python, whether or not you put the condition in parentheses is up to you, right? But in Java, they must be inside parentheses, so there's no choice. In Java, you have to worry, well, in Java and Python, you're worried about the scope of a variable. And so this is a good time to explain how scope affects where you declare variables and where you assign to them. So if you have not heard the term scope, scope is simply the region of code where a variable name is usable, right? So where you're allowed to use a variable name without error. In Java, the scope starts where the variable was declared. So you have to declare the variable first in Java, and it goes to the end of the block in which the variable was declared in. And so in our method max3, we have three parameters, A, B, and C. They're declared in what's called the header of the method. And so these are the variables A, B, and C. They are usable as soon as you get inside the block of the method, all the way to the end of the block that the method is defined in. Sorry, that defines the method. Right. Okay, now here I've got another variable called result. So the scope of result starts here, right? So as soon as I declare the variable and in this case initialize the value, after that I can use result. Right? So I can safely use it here, I can safely use it here, and I can safely use it here, all the way up to the end of the block that it's defined in. All right, so what is the problem here? Or why am I bothering to explain this to you? It's because it's a common error that occurs for people new to Java is that the program will realize, oh, look, I need a variable called result once after I do this comparison between A, B, and C. So I'll declare the variable result here. Right? So the double result is equal to A. Right? And this is what you would do in Python, right? You would just result equals A and away you go. Right? And then when you try to return result down here, you have a problem. Right? So the problem is, right, the scope starts here, right? And it ends inside the block that the variable was declared in. So the block that it's declared in ends here. So in this case, the name result is usable only on that line right there. And of course, after that line, if you're inside the same block, right? Oh, sorry. Right? So you could use it here if you wanted to, but you can't use it outside that block. Right? It's not usable before or after. Right? Similarly, if the maximum value is B and you save the result in a variable called result here, right? The only place result is usable is inside the block, right? So it's not usable down here. So if you write this method in Eclipse or in Visual Studio Code, I imagine, right? The Eclipse will flag this as being an error, right? It'll highlight this line and it'll say result is, there's no declared variable called result. Right? And so that's why I had to declare a result up here, because I needed it down here. Right? So you have to pay a little bit of attention to where you declare your variables and where they are usable once you've declared them. Yes, question.
All variables can work their way into any block. So if result was initialized before the if statement, it can be used in any if statement.
So if it's here, you can use it anywhere from this point down to here, okay, so including if you insert extra blocks. Okay, so yes. Yes. Yeah. Any other questions? Right. So this is one of the implications of Java. So the fact that Java has types and you have to declare your variables and give them a type when you declare them, you have to be aware of the fact. You have to be aware of the scope of the variable. In Python, you don't care, right? You could just write result equals A here, result equals B here, and then return result here, and everything is fine. All right, so if you have a return statement in a method, if a method returns a value, you must have a return statement. You're allowed to have more than one return statement in a method, similarly to how you can have more than one return statement in a Python function. Once you write return, though, you can't add any extra code after the return statement, or immediately after the return statement. Right, so another way to write max3 is to not use a variable called result at all. Right? Simply compare A, B, and C, and if A is the largest, I can simply return A here, and that's fine. Right? If B is the largest, I can simply return B here, and otherwise, it must be C that's the largest, so I can simply return C at the end of the method. If you choose to use multiple return statements, you have to remember you can't put any code immediately after the return statement. The return statement ends the method, right? So it ends execution of the method. So once you return a value, you leave the method. And so if you try to add extra code here, the Java compiler will flag that as an error, right? It'll call the code unreachable, and the compiler considers that to be an error. So you're not allowed to add any extra code here. Some people will tell you that this is bad programming style, right? The fact that you have multiple return statements, they will argue, makes your code harder to read. Right? In a method that's this short, it's probably not really a big deal. Right? You can imagine in a method that's very long, if you have return statements all over the place, it becomes hard to trace through. In this particular case, I would argue that this is absolutely fine. Right? So if you write code like this in this course, no problem. Right? If you want to be strict about it, declare a variable, assign the value to a variable, and return only a single value at the end of the method. Another thing you have to remember is that your compiler is not a mathematician. Well, it's not a very good mathematician. So your compilers do not attempt to perform any sort of logical deduction. Right? And so the rule in Java is that if a method says it returns a value, it must return a value. So you might choose to write your code this way. Right? So mathematically, the maximum value of A, B, or C must be one of A, B, or C. You have to remember Java doesn't know that. Right? All Java sees is code. So all the compiler sees is code. So mathematically, this would be correct. Right? If A is the larger value, return A. Else, if B is the largest value, return B. Else, if C is the largest value, return C. Right? Now the problem with this is that the compiler thinks you may not return a value. Right? All it sees is an if, else if. Right? Now remember, in these kinds of statements, the code here only runs if this condition is true. Right? The condition inside the brackets is true. Right? If that's not true, then it could be the case that this line will run. Right? But that line only runs if this entire condition is true. Right? If that condition is also not true, then this one might run. Right? It might not. That's what you have to remember. Right? It might not run as far as the compiler is concerned. Right? And that code only runs if that condition is true. Right? If none of these conditions are true, you end up down here. Right? And that's all that the compiler sees. Right? It sees an if statement with a condition, an else if statement with a condition, and an else if statement with a condition. Right? So as far as the compiler is concerned, you might end up down here at some point in time. Right? Mathematically, you know that's not the case. Again, your Java compiler is not a very good mathematician. It cannot deduce that this code is in fact correct, right? That you will in fact never get to here. So if you try to write your code this way, the compiler will complain. Right? It'll complain that you have a method that returns a value, right? but it's missing a return statement. So you have to rewrite it in one of the previous ways that I showed you. Of course, the real problem here is that you really don't need this condition, right? If that condition is not true and that condition is not true, it must be the case that that condition is true. So strictly speaking, you don't need the, so the correct way to fix this problem is to remove the if part here. Okay, another difference is Python uses the word and for its logical and operator, and it uses or for its logical or operator, and it uses not for its logical not operator. Java does not use words for those operators. So the and operator in Java is the double ampersand. You have to be careful with this because there is also a single ampersand operator. Right? In Java, if you want logical and, it's the double and. Right? So if A is greater than or equal to B and A is greater than or equal to C, right? And if B is greater than or equal to A and if B is greater than or equal to C, right? If you're writing the ampersand on a test, don't worry if you can't really draw the ampersand. I get this question a lot. It's surprising. So when you go to write your test, I'll often get a student stick up their hand and say, I don't know how to draw the and. It's fine. Just do your best. Right? I will figure it out. If you want or, the Java's the operator is the double vertical bar. And just like in Python, and has higher precedence than or. So here's a little example that of a method that computes whether or not the variable year is a leap year. Right? And so a year is a leap year if the year is divisible by 400. Right? So the year 2000 is a leap year. Right? Because 2000 is evenly divisible by 400. The percent sign is Java's remainder operator. Right? So take the year, divide it by 400, right, and compute the remainder. Right? If the remainder is equal to 0, then this condition is true. Right? So 2000 divided by 400 is 5 with a 0 remainder, so that condition is true. Right? If your year is not divisible by 400, then it still might be a leap year. Right? And so it's a leap year if it's divisible by 4. Right? So year divided by 4, compute the remainder if that's 0. Right? And it's also not divisible by 100. Right? So for example, the year 2100 is not a leap year. Right? It's not divisible by 400. It is divisible by 4, but it is also divisible by 100. So it's not a leap year. Right? And so not equals in Java is exclamation mark equals. Right? Which I think is also true in Python. Yes, I think? I don't remember. I don't program that much in Python, but I think that's also true. Right? So if you want not equals for primitive values, you can use not equals. Equals for primitive types is equals equals just like it is in Python. Right? Any questions so far? Yes? Can you? Yes, I'm going to get that in just a second. Okay, so here we have if the year is, so if it's a leap year, I'm going to return true. Otherwise, I'm going to return false. Right? Now, so this condition, this all works the way it's written because and has higher precedence than or. Right? And so when Java goes to evaluate this expression, right, it sees an or here, it sees an and here. So it computes the this part, the year divided by 4 and the year divided by 100 part first, right? Because and has higher precedence, right? And then it evaluates the or, right? So then it evaluates that condition, takes the logical or with the next condition, with the overall value of this condition. Right? Now, if you don't like that, and a lot of people don't like that because it's not always easy to remember what the precedence of your operators are. You can always use parentheses to force or to be explicit about the order that you want things evaluated in. Right? Parentheses always have highest precedence. And so if you wrap up the or part, the and part in parentheses, then it becomes clear to everybody that in fact you are computing the result of this logical condition first, and then taking the or with the first logical condition there. Right? So you're allowed to use parentheses to be explicit about precedence. All right, so you have to remember here that this condition up here, so year divided by 400, is it equal to 0, is a condition. Right? So in other words, it evaluates to true or false. Right? And this whole expression here right, is a condition, so it evaluates to true or false, right? So if this overall expression is true, I'd like to return true, and if it's false, I'd like to return false. So what does that mean? It means you can just evaluate the condition and return the condition, right? And so a more experienced programmer would almost certainly write the method like this, right? They would get rid of the if statement altogether, simply evaluate the condition, and return the value of the condition, right? So you want to, as you become more experienced in programming, right? So as you work your way through your computing science degree, assuming you're in the computing science program, you want to start training yourself to write that instead of that. If you write this on an assignment or on a test, no one's going to deduct marks from you. It's fine, right? But keep in mind that you want to start writing your code like that as opposed to that. All right, any other questions? Okay, great. Not. The not operator in Java is the exclamation mark on its own, right? So back here, that's not equals, right? But that's not an application of the not operator, right? On its own, the not operator negates the following logical condition, the logical value, right? So assume is leap year is defined in some class called lecture 3, which is in some other package, perhaps, doesn't matter, right? So I want to use the is leap year method to write another method, right? So I want to write a method that computes the number of days in February given some year, right? So if the year is not a leap year, I know there's 28 days, right? How do I compute that it's not a leap year? Well, I call is leap year, right? Pass in the year, right? And negate the result. So the exclamation mark goes in front of the method call, right? So if year is not a leap year, return 28. Otherwise, return 29, right? Of course, you could write this if year is a leap year, return 29, else return else return 28, right? But I wrote it this way so to show you how to use the not operator if you need it, right? So exclamation mark instead of NOT in Java. Another difference between Python and Java. So Python lets you chain comparison operators, which is super convenient in some cases. So here's a little method that does some simple conversion of a number grade to a letter grade. Right? So if your grade is greater than or equal to 80, the result is an A. Else if your grade is between 70 and less than 80, the result is a B, and so on and so on and so on, right? So we're going to ignore A pluses and the minuses and pluses. Right? And so in Python, this is a perfectly valid way to write your condition, right? This is the condition that I'm interested in right here, right? So is the grade greater than or equal to 70, and is it less than 80, right? Unfortunately, in Java, you can't write that, right? So if you want to do a comparison, you're allowed to use one comparison operator. That's it, right? So, unfortunately, what you have to do is you have to be explicit about the and. Right? So Java does not allow these chained comparisons to happen. Right? So the program must use and to separate the two separate comparisons. Right? And so here, if the grade is greater than or equal to 70, right, and is the grade less than 80. Right? If you try to write something that looks like that in Java, the compiler will complain again. Right? Java does not allow that kind of chained comparison. Right? Okay. So that's it for if statements. So if you can write a Python if statement, you can write a Java if statement as long as you remember all the syntactic differences. Right? There's no big difference between the two kinds of if statements. Right. All right. So we're going to move on to deck number 4, which is also called From Python to Java, but it's slide deck number 4. Oh, yes, lists. Okay. And so before you do assignment 1, which will come out in a couple of days, I think, you need to know about how to represent a collection of stuff in Java. And so there's lots of ways to represent a collection of stuff in Java. So Java does have the equivalent of a Python list. We're not going to use that right now. So the reason is because to use a Java list, you really need to know how to use classes and objects, and we're not there yet. So Java has something else. It looks like a Python list. It's not at all a Python list, right? So the similarities are only superficial. So if you want a list or other sequence in Python, you can use the square brackets, right, for indexing and slicing, right? So Python lets you index or get or set an individual value in the list, right? Or you can get a sublist from a list by computing a slice. And so here I make a list called T, right? It's a list of strings, so it has the strings A, B, C, and D inside of it. Right? If I want to get the first element out of the list, I can write T square bracket 0. Right? If I want to get the last element out of the list, right, I can compute the length of the list and then subtract 1. Right? You subtract 1 because the indexing starts at 0. Right? So if you want the last element in a list of size 4, you need the index 3. Right? Or you can use a negative index, which is super handy. Right? So in Python, you could also write T square bracket minus 1, which is nice. If you want to assign a value or assign to an element inside the list, right, you use the square brackets. So T square bracket 1 gets the value B, changes the lowercase b to an replaces the lowercase b with the uppercase b. Right? T square bracket 2 gets the value uppercase C, replaces the lowercase c with an uppercase C. Right? Okay, so Java does have a list, but we're not going to use lists yet, right? So remember that. So in a week or so, we'll start to use lists, but for now, we're going to use something called an array. And so in Java, this thing called an array, it's a container, so it can hold a bunch of stuff, but it always holds a fixed number of stuff, right? So if you make an array of size 5, it always holds 5 things, and there's always 5 things in it, from the point of creation onwards, right? So it holds a fixed number of values of a single type, right? So that's actually quite a big difference compared to a Python list, right? Python list, you can put whatever you want into the list, and you can put however many things you want in the list, right? You can take stuff out of the list. So I'm telling you right now in Java, an array, you can't do those things, right? You can put a fixed number of items in the list in an array, and they all have to have the same type. So I can make an array of length 5 that holds 5 ints. I can make another array of length 3 that holds 3 doubles. Right? I can make another array of size 100 that holds 100 strings. I can't change the size of any one of those arrays. Right? And I can't change the type of element that's in those arrays. So when you make the array, that's when you fix or establish the size of the array. Right? So the length of an array is established when you make the array. All right, so how do you make an array in Java? Well, you can make a variable that can store a reference to an array by writing the element type, square bracket, and then the name of the variable. So that line there simply says collection is a variable that can store a reference. That's not correct. Collection is an array. Collection refers to. Okay, so that line there says collection refers to an array of double values. What you have to remember in Java is that there's no array yet, right? All you have is a variable. So I've got a variable called collection, right? Eventually there will be an array that collection points at or refers to, but I don't have one yet. So I haven't made the array yet. So all I have is a variable. All right, so once you actually made the array, you can then start to use it. So the good news is that the syntax for using an array is pretty similar to using the syntax for using a list in Python. Again, you always have to remember, though, that you're using an array, and this array is a lot less flexible than a Python list. Right? So, for example, there's no slicing of arrays. Right? The array always has the same size. It always contains elements of the same type. No negative indexing, unfortunately. So if you want to work from the end of the array, you've got to compute the length of the array and then start subtracting values. Right? This is annoying if you're a Python programmer. Right? The fact that there's no negative indexing. The no slicing is also a big disadvantage. All right, so if you know the values that you want to put in your array when you make the array, right, you can say what those values are when you declare the array variable. Right? So if I have a small, so if you have a small array, this is useful. Right? If you have a large array, this is not useful because you don't want to type in all the individual values. So here I have an array of length 4. 4 is small enough. Right? I know what I want to put into the array. I would like to put in the values A, B, C, and D. Now, I don't think we've talked about this yet. That thing there, the A inside single quotes, that's not a string in Java. Right? So remember, in Java, all strings are double quoted. So if you see a single character inside of single quotes, that's what Java calls a char. Right? And so char are the individual elements that make up a string. Right? So the character A, right? The character B, the character C, the character D. Right? All characters are one character in length. Right? So you can't have the character AB, for example. Right? That's a string. Right? So individual elements of a string are called chars or characters. Right? If you want to write down examples of those characters or literal values of those characters, you put them in single quotes. There's no such thing as the empty char. So you can't write single quote, right? You can put a space in between the single quotes, but you can't write single quote with no space. Right? So that's we'll talk more about chars in a little bit. I wonder if I've missed that somewhere. Anyway, it's fine. I think we're going to talk about chars when we talk about strings. All right, so you can get the first element out of that array using the exact same syntax that you would use in Python. Right? So the first character in the array, so its type is char, right? Is just t square bracket 0. Right? The last character in the array, so the D, right, is found at index 0, 1, 2, 3. Right? So that's the length of the array minus 1. To get the length of the array, right, you write the array name dot and then the word length. No round brackets here. Right? So it's t dot length, nothing after the length. If you have an array called x, it would be x dot length, right? You have an array called a, it'd be a dot length. You're not allowed to change that value length, right? So you can't write t dot length equals 2, for example. That doesn't work, right? So the length of an array, the array knows how long it is, right? So the array t knows how long it is. It's t dot and then length, right? Minus 1 because we're starting indexing at 0. Right? Assigning values to the array, exactly the same as in Python. Right? So t square bracket 1 gets the value uppercase B, replaces that B with the uppercase B. So superficially, they look exactly the same. Right? That code looks more or less the same as that. Right? Okay, so if you know the values that you want to put into your array, right, you can initialize the array by writing the braces and then a comma-separated list of the elements, right? So that's called initialization. So declare the variable, right, equals, and then braces, and then your the sequence of elements that you want to put in the array, right? That's fine. What you're not allowed to do in Java is you cannot use the braces like this to create an array variable and assign it, and assign that to something, to an existing array variable. So you can't write char square brackets u, right, semicolon, and then on the next line attempt to write u equals squiggly braces x, y, z. Right? You can do that in Python, right? You can write u equals square brackets whatever you want, anywhere, anytime you want. In Java, you're not allowed to do this. Right? You can only use this brace notation when at the point where you declare the variable itself. Right? So you're not allowed to do that. All right, so normally though, you don't, you probably, in most cases, you don't know the values that you want to put into the array. Sometimes you do, but in most cases you don't, right? And so normally in Java, in a language like Java where you're working with arrays, you know how big the array is that you want to use, but you don't know what the values are that you're going to put into the array. And so to create the actual array, normally what you do is you use this operator called new. So new is also a keyword in Java, right? You're not allowed to have a variable called new. It's reserved for the use of the language itself. Right? So you use this thing called new, and you say how long and what element type do you want in the array. Right? So here, I've got my variable called collection. Right? Collection refers to an array of double values, but there is no array yet. Right? To create the array, you write something like new. In this case, double, because I want an array of double elements, and I would like 10 double elements. Right? So new double square brackets 10 makes an array of length 10, sets all the values to 0. Right? I now have an array which I can now assign to collection. Right? And so that's what that line right there does. Right? So that value 10 is called the length or the capacity of the array. Right? How many elements are in the array? Remember that collection will always be, this array here is always an array of length 10, right? There's no way to change the length of that array that was just created. Okay, so arrays of primitive types, all of the elements get initialized when you use new, right? So in other words, when you make a new array of primitive type, all the values get set to something. So here is an array of Boolean, right? So new Boolean 3, right, makes an array of 3 Boolean values. All the values are set to false in Java. You don't have to remember that, right, for the purposes of this course, right? But they do get a value. So you end up with an array of 3 false values. New int 4 makes an array of 4 ints, right? They get the value 0. New double 5 makes an array of 5 double values. They all get set to 0. Right. Another awkward thing with arrays in Java is that to print them out, you can't just use system.out.println. Right? If you try to do this, you get a funny result, which I guess is worth showing. Just a second. I just want to quickly look to see if I already have an array example created. Okay, I don't. So I'm just going to make a new class. Array example. I'm going to put in a main method. And I'm going to make my array. So I'll make an array of Boolean, I guess. So Boolean square bracket boo equals new 3. Right, so there I've made a variable that can hold a reference to an array of Boolean. Right? On the right-hand side, I've made an array of 3 Boolean values. Right? I'm now going to try to print it out. Oh, if you're wondering how I'm doing this, in Eclipse, it's really awkward to type out system.out.println all the time. So you can just type in sysout in Eclipse and then do control space. Different versions of Eclipse handle this slightly differently. I'm using a slightly older one, so it simply replaces sysout with system.out.println. Your version of Eclipse might ask you what you want to do with it. And on a Mac, I don't know if it's control or command. It's probably command space. So there's a shortcut for typing in system.out.println. Okay, so if I just print out the variable like that, you're going to get a funny result. So you get this weird result that looks like that, right? And so you're going to get square bracket and then some what looks like a nonsense sequence of letters and numbers, right? So if you do that, what Java actually prints out is the reference to the array. So that is Java's way of telling you something about where the value of the reference that's stored, right? Remember, I haven't told you this yet. The arrays are reference types in Java. They're not primitive types. The elements in this particular array are little b Boolean. So the elements in the array are primitive values. The array itself, or the array variable itself, is a reference variable. So it holds a reference. So when you try to print out the value of the array, you don't get the elements in the array, right? You get the, whatever this thing happens to be, which is not useful for our purposes, right? If you want to see the elements of the array, you have to call a method that converts the array or computes the string corresponding to the elements of the array. So the method looks like this. So you need to use arrays to string. There we go. So if I run this example here, you're going to get what you want to see. Right now you see that you get square bracket, false, 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 separated with commas. Right? And so this method here, arrays.toString, right? So number one, the class called arrays contains a bunch of methods that operate on arrays. So if you're working with arrays, it's often useful to look in that class to see what methods are there. The method toString takes in that array and converts and computes the string representation of the elements of that array. Right? So in other words, it looks at the array boo, sees there's 3 Boolean values, right? And then it creates the string that has a square bracket to indicate the start of the array, right? Iterates over the elements of the array, right? Computing the string representation of each element. Right? And so here you can see that the 3 elements that are stored in the array are false, false, and false, right? And that will always be the case in Java, right? So Java says that Boolean arrays are always initialized to all false values. Right? So remember, if you want to print out an array, you probably have to call another method to convert the elements of the array, or to get the string representation of all the elements of the array. Oh, sorry. Oh, so this table shows you the default values of all of the primitive types. It's not worth committing to memory at this point in time, right? But be aware of the fact that when you make an array, all the elements of the array get set to something. Right? Okay, if you want to set the elements of the array all to the same value, you can use this method called fill, which is also in the arrays class. So instead of having 10 zeros, right, you might want 10 ones instead. So here's my variable sum doubles. On the right-hand side, I make an array of 10 doubles. Right? If you print that out using arrays.toString, you'll get 10 zeros. Right? If you would prefer to have 10 ones, you can either write a loop and fill in the values yourself, right? Or you can use fill. Right? So fill fills in all the values for you, in this case to 1. Right? So arrays.fill, give the name of the array that you would like to fill. Right? So I'd like to fill sum doubles with the value 1. Right? So useful if you know that you want to set all the values of the array to some other value that's not 0. Right? If you want to do something more complicated, like do 0 through 9 or something like that, or 9 to 0 or something else, you now have to write a loop and fill in the values yourself. And we'll get to loops probably not today, so that'll probably be in the next lecture. If you want the number of values in the array, or the number of elements, or the length, or the capacity, that value is stored in what's called a field of the array. So collection.length is a field that holds the number of elements, the length of the array, sorry. Right? And so that field, or that value, variable, I guess we can call it a variable. So that's a variable, you can't change its value. Right? So if you try to write collection.length equals 4 to change the length of the array, that doesn't work. Right? And so the compiler will flag that as an error. So this is a read-only variable in Java. Right? Remember, it's not like the Python length function, right? So len round brackets t is how you compute the length of any sequence in Python, which is nice, right? That's really nice. You have the same function that computes the length of any sequence. Doesn't work like that in Java. Right? So if you have an array, it's collection.length. If you have a list, it's something else. If you have a string, it's something else yet again, and so on and so on and so on. Right? So just like in a Python list, the elements of an array, the values in the array are called elements. Right? Again, just like in Python, you use a zero-based index to access the elements. There's no negative indexing. Right? This is useful to remember, right? Because you often want to start working from the end of the array. If you want the last element in the array, it starts at index length minus 1. Right? So the last valid index for the array A is always A length minus 1. You access the elements just like you access the elements of a Python list, remembering that you can't use negative indexing. Right? So collection 0 gets the value 100. Right? If I want to get the value of the first element, I can write x equals collection 0. Right? And all the way up to 9. If you try to go past 9, so if I go to 10, right, that's the 11th element of the array, which doesn't exist. So in Java, you get what's called an exception thrown when you try to do this. So let me just show you this in Eclipse. So here's my Boolean array of length 3. I'm going to try to get the element at index 3, which doesn't exist. Like that. Right? So notice here, the compiler can't help you with this. Right? All it sees is an indexing operation with an array. Right? The index is not negative. So as far as the compiler is concerned, this might be okay. Right? So there's no red X here or anything like that. Right? You're not going to get any help in this case. If you run the program, you'll get an error. Right? So when you run the program, we get it prints out the reference to the array, then it prints out the elements of the array, and then when I try to get the fourth element of the array, I get an exception. So here the program stops running, and you get an error message. Right? It tells you where it happened and what has caused the problem. Right? So here you see that the problem is caused. Right? I tried to use the index 3 for an array of length 3. Right? The last valid index for this array is 2, so that's not a legal line of code. Right? Yes, question?
Do you have to write the Boolean before assigning that to Boolean 3, or could you write Boolean 3?
I could write boo3 equals something, so true or false in this case. So I could write that, that's fine. Right? So that's, well, it's legal to write, but you're going to run into the same problem. Right? If I run that again, I get the same exception. Right? Index 3 is not a valid index for this particular. Yeah. Right? So in Java, if you, when you use an index that's not legal, an error gets caused. So you might have been told this in Python, you may not have. Right? In Python you can raise an error. Right? The programmer can do this, or Python code can raise an error. Right? And the way you do that in Python is you write raise and then the name of the error that you would like to raise. So Java doesn't have these things called errors. Java calls them exceptions instead. And the terminology in Java is that you throw an exception. So here, when the program runs, right, the Java virtual machine detects, hey, there is no fourth value in this array. And so an exception is thrown. Right? When an exception is thrown, if the exception is not handled by your code, we'll talk about how to do that later, right? Eventually your program will stop running, right? And an error message, if you have a console attached to your to your computer, you'll get an error message, right? Which is that error message right there, right? So that's similar to a Python error, if you know what a Python error is. Oops, sorry. All right, so I guess that's a good place to stop. So the next lecture, we'll talk about loops, and then you should be all set to write your first assignment.